Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we'll solve another question from Leetcode itself. So let's get started. Yes, so today we have find the count of good integers. Yeah, and this question tagged as a hard, and I also feel so like it's obviously a really good questions on combinations of various topic like a deep level mathematics of permutations combinations. This is needed for sure for to solve this out. Yeah, so we will first try to understand the problem statement, then we will go through the intuitions building part, and post that we will do the code iteration. Yeah. So what they have given, you are given two positive integers n and k. So they have given two positive integers n and k. An integer x is called k palindromic. An integer x is called k palindromic if x is a palindrome. I guess you guys know what is palindrome. So a number is palindrome, which is if you go from, if you read it from front, like in the forward go, if you read it, and if you can read it from the backward go, both the cases the numbers are same. Both the case the number is same, because on this example where I am hovering my cursor, you can see, right? So 1 to 1 is a palindrome, while 1 to 3 is not, because 1 to 1 if you read from forward and 1 to 1 from backward, it's only 1 to 1. And x is divisible by k. So if we are going to consider x is a k palindromic, then the first condition is x should be palindrome, and x is divisible by k, and x is divisible by k. It's quite straightforward, right? And an integer is called good if its digit can be rearranged to form a k palindromic integer. If you so on this line actually the major difficulty lies of this particular question. If you not able to understand on the first go, I will iterate you to the test cases. You will definitely get what actually mean. So a particular integer is good if its digit can rearrange to form a k palindromic integer, and we just understood what is actually k palindromic integer. Number should be palindrome and it should be divisible by k, then it is k palindromic. And the rearrangement part I will explain on the test cases. For example, or also they have given an example also. For example, k equals to 2, 2020 can be rearranged to form k palindromic integer 2002. So 2020 is also a good number, because it's we can rearrange its digit, digits to form a k palindromic number, to form a 2002 is a k palindromic, that's the for sure. But 2020 is also right, because with these operations we can rearrange its digit, whereas 1010 cannot be rearranged to form a k palindromic integer. You can try, but you should not be able. So, and finally we have to return the count of good integers containing n digits. So you only have to consider the numbers which has exactly n digits, right? Then they have given to us. Now note that any integer must not have leading zeros. That's I guess quite obvious. So you can't say like if I am asking you to a two digit number, then you can't give me 0 1, because 0 1 is actually 1, right? So that is not a 2 digit, that is 1 digit number. So with leading 0, the number is not going to consider at all, right? It is as simple as that. They have also mentioned same, you can read on your own. So yeah, now on this test cases you can see we have to consider in n equals to 3. So that means we have to consider all the three side permutations, all the three side good numbers, all the numbers having digits length of 3, and k factors they have given to 5. K factor is given to 5. So the number should have 3 digits, and the number should be divisible by 5. And so that is and the number should be palindrome on itself. If these all conditions is satisfied, then we will consider this number as a good, but not a number which is not, maybe on the first go not satisfying the conditions, but if you do the rearrangement of the digits of this particular number, then it will. So if you rearrange the digits, then maybe it is going to be palindrome also, and it is divisible by k also. So here you can see, right? So 551. So some of the good integers they have a given example. So 5152 is for sure, because if we read from forward it's 515, from backward 515. But 551 is also a good number. It's also a good integer, because 551 can be rearranged. It can change its digit a little bit, do a tweak on its digit, and it can become a 515. So on the bucket of good integers which we have to return in our answer, 551 is also a valid guy. 551 is also a valid guy. Like this way, I guess 155 is also a valid guy. That's for sure, because that digit is also going to make a tweak on itself and become 515. So like this way, there can be multiple good integers, and we have to return the count of them. We have to return the count of them. 525, because it's already a k palindromic. Like this way, they have given couple of examples, but I guess you guys get the gist of this line. So we are considering a number good if on the very upfront, if at the very upfront it is not a k-palindromic, but it can make a tweak of its digit, and it become a k-palindrome. It's become a k-palindrome. So that numbers also we have to consider as a good integer buckets to our answer bucket. Here also you can see n is 1. So we have to consider all one digit number which is k-palindromic. So here you can see only 4 and 8 is in our bucket. So we are returning 2 to the answer. And that is the very big test case they have given for n5 and k6. The output is 2568. Yeah, and constant you can see, I think it's quite obvious, like n can go to as big as 10. So the digit length can be the number you are considering max of 10 digits, and it the divisible factor, like if it is k divisible, the k can go to 1 to 9. So yeah guys, I guess you guys are able to understand the question. Now the challenge is to like figure out a solution on this. So if it is a hard level question, you have to break the problem into some multiple sub problems, like what actually we are looking for. So now let's go to our OneNote. If write some very generic test cases, we will try to very generic, very big test cases. Let's suppose how many I know my n can grow to as big as 10. So it can has maximum of 10 digits, right? It can has maximum of 10 digits. So what happens to my OneNote? Okay, so let's suppose I am writing 1 2 3 4 5 6 7 8 9 10. So let's suppose I have total 10 positions to fill. So first we will do very intuitively. We will try to find the first we'll try to find, because we know on the same go we are not able to solve the entire problem. On the first go you are not able to solve the entire problem. See, you have to. So if it is a hard level problem, try to break it down. What actually on very initial go you can do? We can try to find the k-palindromic integers of length n. Initially we can try to find them. We can try to find them. And top of that, your brain is explicitly stating, hey man, if you are able to do so, then mostly I think your job is kind of done, but I'm not sure. There can be edge cases, but I'm not sure, because if you are able to pinpoint a particular number which is a k-palindromic and also has n digit, then we maybe can do kind of permutations and combinations, any mathematics things we can do on that, maybe some randomness on its digit, and we can consider how many permutations and combinations we are able to generate, which are also good, because we know there is a liberty they have given. The numbers digits can change as many times as they want, and if they are also able to generate a k-palindromic integers having n digits. So we are doing reverse. We are first generating the k-palindromic digits, and then we do the randomness of its digit. How we can do? By using the simple permutation combinations. So the main challenge initially, maybe point 2 is also challenging, but we don't know. First do generate of the first k-palindromic integers of length n. So we are going to take as the largest value, because if we are able to solve for n equals to 10, which is the maximum value, then others like n lesser than the 10 value is going to be a cakewalk. So we are going to try for n equals to 10, and it is also going to be give you an like very clear edge cases which you have to consider, because I have did the exact same things on my pen and paper work, just to jump on the find out the most optimal solution. So that you have to do. If you can write the whatever the maximum value of the constant, if you can write a generic solution for that, then all the test cases below of that is going to be satisfied for sure. So that's the reason I am taking the what is the maximum value of n. I am trying to solve for that. But maybe I am not able to. But let's try to solve for n equals to 10. What is the largest value of n we have? We have total of 10 places to fill. 10 places to fill. Now how we can fill? I know it's palindrome. So just take a note, guys, how greedy I am. So I know, if as it is a palindrome number, if I am putting here as x, this position is by default going to be x. If I am putting y here, this position y here. If I am putting z here, this position also z here. If I am putting a here, this position also become a here. If I am putting b here, this position is bound to happens b here, right? Exactly, because it should be palindrome. So what actually we have to try for all the k palindromics numbers we will try to generate for n equals to 10, right, for n equals to 10. So and they told, right, they told if this first number, how many ways, how many liberty you have to choose the number of x, how many liberty you have to choose the number of x, how many liberty you have. It can't be 0. Okay, I'm not taking 0. I will take from 1 to 9. I have the liberty to choose from 1 to 9. And for other places, yes, I can take 0. I can take 0 also. So I will take 0 to 9. So for all other, it can be 0 to 9, 0 to 9. I should have the liberty to choose from 0 to 9. To choose from 0 to 9. Very clear, very clear. Because on the first number, if we choose a 0, then it is going to be less than of n digits, right? Because leading 0 is going to be negated altogether. But from very next we can, right? So that is the very initial observations we have to take a note when we are building our k palindromic strings, k palindromic integer, whatever it is, when we are trying to build that. And how many digits, if n equals to 10, how many digits we have to search for? We are going to do the randomizations for this, sorry, not randomizations, like choosing from 1 to 9 for this, and this is going to be set automatically. Similarly, we will do for y, this is going to be set automatically. We will do for this z, this is automatic. We do this is automatic. We do this, next v is automatic, because by rules of palindrome. So whatever the length of the strings is given to us, we will try for half. Because I know for the right portions is already sorted. I know, because the same things I have to put my right, because it's palindrome. But okay, Shouvik, it is for even length, so you are fine. What about odd length? I am taking small example. Let's suppose 3. You are putting a here. You are bound to put a here. You are going to put b here. Fine. So for like odd number, how many places you can do the randomizations? 1 place, 2 place. So for 3, the answer should be 2. For 10, you have the randomizations options for 5 indexes. For 3, it's 2 indexes. So it's nothing but it's of math.celof n by 2, maths.celof of n by 2. So that many places we can do the randomization, and the very next part is going to be auto set, because it's palindrome. I think you guys agree to me. Right? This formula is applicable for odd length and even length, both, right? It's very straightforward, and if you are not able to understand these things, then this question is not for you. I'm bound to say this, because this is quite a master level question. So there are lots of topics I'm just going to teach you with these particular solutions, and if you are not able to, so that is the most generic things. I guess you guys are getting this, but if you are not, please rewind the video, then you will definitely get. So I did nothing. I have just put the same digits at first. Last is auto set. And how many options we have? It is nothing but math.celof n by 2, which is generic for both. So I am pretty sure if it is a 10 length, I have to do the randomization. I have the opportunity to choose the numbers of n by 2 place, correct? Obviously math.celof of this. So what I can do. So for x, there can be for a particular x value, there can be multiple y values. There can be y1, y2, y3. Similarly, for a particular y, there can be multiple z values, z1, z2, z3. Because if I choose x equals to 1 here, so for 1, I have to choose for other. If you are not able to understand, let me write it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you choose here 1, then you can choose here 2, 3, 4, and if you choose 2 here, then for this particular index, you also have the options of choosing 1, 2, 3, 4, like this way of 9. And here also, like you have to choose the options of 1 to 9. So for every index, from every index, we have to run a loop. We have to run a loop. We will try. So for first, we have options of 1 to 9, and for each 1 to 9, we can choose another 0 to 9 for the next index, and if you choose any of 0 to 9 for the second index and onwards, you for the next index, for every index of previous, you can choose a 0 to 9 for that particular index. So how many loops you are going to iterate? How many loops you are going to form? For this index I need a loop. For this index I need a loop. Like for this index we need a loop. For this index we need a loop. Like this way. If n equals to 10, then what is the places we told we are doing the randomizations. We are doing the permutations. Like we are trying for all the possible numbers. Is nothing but math.celof n by 2. Math.celof n by 2. So that is nothing but my loop check. If I can assign it to a variable's loop check. Loop check is nothing but how many positions we have to do the loop check. It's nothing but of math.celof n by 2. math.ceil of n by 2. So that many places we have to do the loop check. We have to do the nesting. We have to do the nested loops. So now can you guys tell me? Can you guys tell me one thing? I am doing the maximum test cases, n equals to 5, n equals to 10, and if you are able to understand n equals to 10, that is just a copy paste of code. As simple as that, guys. So now we understood. We have to run a 5 nested loop for n equals to 10. One for if I can write it for a in range of, first loop is run from 1 to 9. We just explained, because if we are taking 0, then we are going to encounter a leading 0. For b in range, how much? 0 to 9. Same way we can write for c in range 0 to 9. Like this way we can write for d in range how much? Again 0 to 9. And finally for e in range it can also go from 0 to 9. And let's suppose I am going with, I already took n is static for each test cases. So what is the n value? I can try to make a list. Whatever the n value they have given, I can put it all to of n size, because I know I have the liberty of n size of a list, where we can do the permutations. And when we are doing so, so for this index, so for this place, what we have to store here? LL of 0, the very first we can store as a, because that is the changing variables of my initial loop. And LL of minus 1 we can store it as a, right? Similarly for this index, similarly for b, can you guys tell me? Yes, Shouvik, it's very simple. LL of 1, now we are at second index, we are going to store b. And for second last index, LL of minus 2, so Python support negative indexing from back. So that is the point to note. If you don't know, then you can just go to iterations. So the very last index is stored. If you do a LL of minus 1, it is giving the very last, LL of minus 2, second last, like this way. And similarly, I guess you guys got the gist. For this index, if I can pull it here, if it is a C loop, then LL of tell me guys, 2, I will store it C, and LL of third last minus 3, I will store at C, because I am following the symmetry as it is a palindrome. So like this way, I have filled my LL. When I am running this E loop, I have already done. So here what I will do. So for D, LL of 0, 1, 2, 3, 4, right? LL of 4 I will put as E, and LL of, tell me guys, minus 5 I will put as E. As simple as that. Yes, I will do for other loops also. So now I have my LL ready, which is size of 10. Because I choose n equals to 10, or whatever the n value, my LL is filled with this. Now what we have to check? Very simple. You just have to check if the LL, now you have to store your LL to build a number with this, right? So you have every digits you have stored in a list. Now just have to, you can do a string concat, but I don't like the, if the question is playing with the game of number and you can do the typecasting. I personally don't like the typecasting things. So that's the reasons. So on this particular question, they're basically looking for some mathematicals, only just using the mathematicals formulations. But yeah, like you can make your stringify the actual LL by, so whenever you are iterating to your LL, you can stringify it and then you can do a int of that. As simple as that. Then you can get the merging of the number that actually formed by these combinations, by this five nested loop combinations. So I am doing it in a smarter way. You guys can see. So I am taking a num to 0, and I am running a loop. I am running a for loop for each in LL. I am taking every of them from my LL, and I am doing my num into equals to 10, and I am doing num plus equals to each. I guess you guys got these things, what I am doing. So when I am multiplying a number with 10, it is just creating a number, just creating a place to its right, so that next number is going to happen. So let's suppose if my LL is something like, it's very like childish things, but if you don't know, I am, for that reasons I am giving the gist. But if you are solving this question, that is like a cakewalk. That should be the cakewalk type of things. So let's suppose my LL is storing 1, 2, 3, 4, and I basically want 1, 2, 3, 4 as a number of this. So how I am doing, I took a num equals to 0, and initially when my LL is 0, it is multiplied by 0 and add by 1. So my num becomes 1. The first go, and on next go my num is 1, and when you doing a multiply of this, num is become 10. because I am doing a multiplication by 10. So it is creating a, so here you can see it's created a place, where you can add your next digit, and I am doing a, after that I am doing a plus 2 to it, so it's become 12. And on very next go, I think so you guys got the gist. I am doing a multiplication of 10 and it is become 120, and after that I am adding a 3. So here just by multiplying I am creating a place where I can add the next digit. So here you can see it's become 1 2 3, and post that again I am doing a multiplication of 10, it's become 1 2 3 0, and I am adding a 4. So like this way I am going to get a 1 2 3 4. So that's the guidance what I am doing. I have put it here, but yeah, that's you guys should get on the very first page. So yeah, so that's the things I am doing. So my number is ready, but you can do stringifies and then intify, that should also work. But yeah, that is first also, because on the one go we are doing, otherwise you have to do a couple of goes, right? So my number is ready. Okay, Shouvik, if your number is ready and we are following, so now what we have to follow, we are looking for k palindromic n digits number. So n digits is by default followed, because we are putting everything to my n, to my ll, which is already a n digits, and we are formulating how many loops we have to run to build my n digits ll. So that too we are by default following. And palindrome, are we following palindrome by default also? Yes boy, we are following palindrome also by default. So when how, because when we are putting a value to the first, and we are also pushing the value or putting the value to the last also. So like this way we are also palindroming, we are also following palindrome. So what remains? This k factor y is remaining. So now it's very simple. Whatever the num you build, can you make a check if your num modulo k is equals to 0, then it is a k palindrome for sure with n digits, right? So that's extra checks. So that's checks we just have to follow, because other things we by inheritingly we follow. We are following, right? So if that case is followed, then we have our k palindromic n digits length number is in our hand. Now we have to think. Now I guess we are able to build our first logic. What was our first logic? So our first logic was k palindromic n digits length number building. So we are able to do. Now we have to find all the permutations of this number, Now what we have to find? Let me write it here a little bit clearly. So now we have to find the n digits number we build. We have to find the same n digits number, by permuting or randomizing the digits. Agree? I guess agree. Everyone agree? So, now okay, it's I think Shouvik, it's quite straightforward, I guess. Okay, let's see if it's straightforward or not. So we have our 10 places, let's suppose, has set, and now we have to find the permutations out of this, right? A permutations out of this. So how many places we have? We have total n places, as we all know, n digits length is, and there can be some. So if all the numbers are unique, all the numbers we have put, if all are unique, so what is the answer? How many permutations we have? It's very simple. It's n factorial. But for our case, I am pretty sure. So what is the number I am putting here? I am putting the same number last. So there can be repetitions. So if there are repetitions, what is the formula boils down to? Your n factorials is going to divide by k1 factorial into k2 factorial into k3 factorial, like dot kn factorial. I think it's very 11 standard maths if you are on Bengal board, and for ICSE CBSE it's on 8 or 9 standard mathematics formula, which I just written. I am not going to explain what is the intuitions behind this, but I guess you guys should have heard of this formula, otherwise this question is not for you, that's the for sure. So if there are repetitions, if there is all unique, then n factorial. If there are repetitions, we have to divide the n factorial with the repetitions factorial. Let's suppose 5 is occur 2 times, so there is a 2 factorial divisions for 5. Let's suppose 3 is occur 3 times, so there is a 3 factorial divisions for 3. Let's suppose 7 is occur 2 times, so then there is a 2 factorial divisions of this particular number. So like this way, which numbers has occurred multiple times, we have to divide the factorials value of this to this particular total n factorial. So that is of 8, 9, 10, 11 standard maths, I am not going to explain. So this formula we definitely need here. We can apply this formula directly. But man, wait. If there are some zeros, let's suppose your number is 1001. Let's suppose your number is this. Then if you apply this formula, the n factorials you are taking, this n factorial divided by 2 factorial into 2 factorial. So n is nothing but 4 here, right? N is, for this particular case, is 4 here. Then if you apply this formula directly to this, then this can randomize your 0 also in the 4 places you have at. Then your 0 can also come like this way. So it has leading zeros, and if it is a leading 0, then that is not a valid answer. That is not a valid answer. So okay, now it seems to be really challenging. So we might have 0. How we have 0? Because I guess you already got it. Because only for outer loops, we are running to 1 to 9. But for other nested loops, we are running from 0 to 9. For other loops, we are running from 0 to 9. So the numbers, the final number we just built, so this can has 0. So the num we just built, it can have zeros, intermediate 0. It can have. Very true. Okay. Now if it has intermediate 0, then what else? Then I can't bring the liberty of the zeros to come to very fast. So that liberty I can't do. But else what is the place? If it is a 4, 1, 2, 3, 4, 5 other 4 places, so this place is not for 0. This place is not for 0. But for other places 0 can do the permutations of its own. So this place for 0 is valid. So for 0, how many places, how many good places we have? It's nothing but n-1, agree, right? Because only the first places we can put our 0. But for other places we have the liberty to put the 0. And out of them, how many zeros we have? So we have total n-1 places where we can put our 0, and how many zeros we have? Let's suppose we have x 0. So n-1 of x. So that many ways we can put our 0. Agree, right? So if we have x zeros, and we excluding the first index, how many places we have? We have n-1 places, and we have to put x zeros to them. What is the combinations way we can pull the x zeros? We can pull the x zeros of n-1 ways. So we have the opportunity of n-1 ways, and we have to pull x out of them. So the formula is n-1 cx. n-1 combinations of x. n-1 cx. This formula is also a class 9 to 11 standard maths has this formula written, right? And I think we have done to our zeros part. Zeros contribution. If I can write it to zero contribution to our answer is nothing but n-1 cx. If we have x zeros, and the n factor is given to the, what is the input n is given to us, because we have first one is not valid, else we can use. And for non-zero we will use our formula. What is the formula we have built for non-zero? This formula. Yes, I can use. For non-zero I can use. Only the problem for zero. Because if we use this formula for zero, then for zero it's pushing the 0 to the leading also. So we are stricting this by using the formula for 0. And for non-zero, what is the non-zero contribution? Non-zero contribution is nothing but how many places we have after putting 0. How many places we have? If there are x 0, so we have n-x places, that's for sure. And on n-x, so we have n-x places, and out of them how many? Again same, k1 factorial, k2 factorial. How many non-zero numbers? Repeated occurrence factorial. We can use the same formula. And what is the answer then? So for this particular num which is followed our block, if num modulo k is equals to 0, is nothing but it's 0 part contribution into non-zero part contribution. So that is, we are going to add to our answer plus equals to 0 contribution and non-zero contribution. So yes guys, this problem is, I don't have to say as simple as that, it is as challenging as that, I have to say. But yeah, it's quite awesome, quite like like different level maths is involved. So you have to very strong of these permutations combinations. One is like applying this formula for 0, and for non-zero ones we are going to apply our standard formula, but excluding the zeros. If we have x zeros, then n is going to be reduced to n minus x, because we have putting zeros, we have n minus x extras by left. Basically by putting x zeros, we have n minus x remaining places for non-zero. So we can do the game in n minus x places. So n minus x factorial divided by the non-zero numbers repeatable factorials divided by the non-zero numbers repeatable factorial. Yeah, so that's on the explanations part and the intuitions building part, and now we will go to the code iterations. You will definitely get the gist. So I will explain for 10, or so if it is, I know how many loop check we have. We already discussed it is nothing but math.ceil of n by 2, right? So if it is 10 or 9, the formula is same. We will go to this particular if block, and for like 7 and 8 it is also going, it is going to get on the loop check equals to 4. So loop check factor I already explained. So I will explain that n equals to 10 factor, which is the most complex part. Other, it is just a copy paste. I will otherwise also I will going to explain, but other part is just a copy paste. So if you are able to write for n equals to 10, other is just a cake for you. So what actually we need on the very initial, we definitely need factorials, because you saw on multiple places we are doing factorials. So the best things, if we can compute our factorials on the very first go, because we know we are doing the nesting, we are doing the nested for loops for 5 nested for loops. So we at the worst case we definitely need a 5 nested for loops of length 10. So rather than and within this I will definitely avoid to do any further computations. But if we definitely need to do the computations, we have to do. But the factorials finding these things, we will go on the very earlier. So what is the maximum factorials they can ask for? They can ask for n factorial. And as it is a zero based, so initial mental model, I will calculate all factorials till n factorials. I will compute and store it to a particular list or array, whatever you want. So that's exactly I am doing. So I have initialized my fact with 0 into n plus 1, and I am storing fact 1 and fact 0 to be 1 and 1, and I am doing the standard factorial things for I in range 2 to n plus 1. I am doing fact of I is equals to I into fact of I minus 1. What is the last value we have? We just did a multiplications with the I we have. So I have calculated all the factorials till n. So whenever there is a call for, we have to find n factorial, n minus 1 factorial, n minus 3 factorial, any factorials I can give you in big of ones, because I am free computing before of nested loop, before of my nested loops. Very fast I will do this. And then it's obviously we will create our LL, the LL that we just discussed, to 0 into size into n. And I have initialized my answer. And loop check is nothing but math of ceil of n by 2, n by 2. So that many loops we need. So if my loop check is coming to be 5, so 5 nested loops we need. 1 on A, 1 on B, 1 on C, 1 on D, and 1 on E, right? We need 5 nested loops for sure. For loop check size is 5. And how we will loop check it? Math.ceil of n by 2. We explained already. And what we are doing of every loops, we are setting, if it is a, then we are setting first and last. For next, second and second last, third and third last, fourth and fourth last, fifth and fifth last. Done. Very good on this till this point. Now what do we need? Ask yourself, guys. What do we need? We have to build our num. How we are building our num? We initialized our num to 0. And we are iterating to our for each in LL, and we are doing num into 10, num plus each. We also explained this. We also did a dry runs on OneNote. So I guess it is also very clear to you guys. So we are doing the for each in LL, and we are building our num. So we have initialized our num to 0, the exact same things that we just explained on the one. After that, we know for some numbers there can be repetitions, because we are doing like this way, right? So when we are putting this B, we are putting at two places, so for sure. For first and the last. For A it is first and last, for B it is second and second last. C, third and third last. So like this way there can be repetitions. And here also, as we are running B in range 10 and for C in range 10, so B and C can be also same. So there can be more repetitions. So there can be the k factorials, n factorials divided by k factorials we are doing. So for this we need to store the k1, k2 factors, k3 factors that we just saw. For this we need to store the frequency of their occurrence to a dictionary. So that's the reason I am taking a default tick of it. And we know how many 0 we need and how many non-zero we need. So we definitely need the count of them. So that's the reason I took these two variables also. And when I am iterating to this LL, I am also updating my this thing's also going to be ready. This thing's also going to be ready for sure. So if it is 0, then I am increasing 0, else I am increasing non-zero, and I am doing d of each to my dictionary also. And rest, when we are doing our job, whenever it is divisible by k, then only we are doing our job. Right? These things just ignore, guys. These DP things just ignore, that I not explained yet. I will explain this. So apart from that, understood the rest part. That is the zero contributions. What is the zero contributions? Fact of n minus 1. Because what we are doing, I guess you guys know about these things. If you not know, I am just quickly writing. So what we saw, n minus 1 c x. X is nothing but the zero count. So what actually n minus c? I am damn sure you guys know this NCP. So it is nothing but n minus 1 factorial divided by x factorial into n minus 1 minus x factorial. So I am assuming that you guys know about NCP, NPC, like these things. Sorry, NCP. I am like doing the wrong. NCX. If I am going to ask you NPX, I guess you guys know about the formula of this. It's very basic things for this particular question. So exactly that things I am doing. So if it is an NCX, so what it is, fact of n minus 1, because for leading 0 we are not considering the first places, and rest is fact of 0. How many 0 we have? X is 0, the x that we are discussing, and fact of n minus 1 minus 0. So that exactly I did n minus 1 c0. The formula should be this. I guess it's very childish things. You definitely need to know this. And non-zero contributions, how we will calculate? It's definitely for how many places we have after putting 0. What is the non-zero numbers we have? It is n minus 0 non-zero places we have, and I am doing a n factorial on this particular case is n minus 0 factorial, because I guess you remember, right? Here we discussed it's nothing but on our main formula, it is go down to n minus x. So x is 0, so n minus 0 factorial divided by k1 k2 we will do. So that is the fact of n minus 0 we are calling our fact function, and then we are iterating to our default dict, because we know the frequency count to divide the k1 factorial, k2 factorial, k3 factorial. We for this we are iterating to our default dict, and we are only going to consider the non-zero ones. If ITR is 0, then on that case we are not going to consider it, because for zero contributions, everything I have done in the zero contributions variable, and I am building on non-zero contributions. So non-zero contributions, if ITR is 0, then I am not considering. If it is non-zero, then non-zero contribute we are dividing with fact of factorial we need. So basically this is k1 factorial, k2 factorial. So fact we are calling. Now k1 is what? dd of ITR. What is the number of occurrence for this particular ITR? Is dd of ITR. So I am doing factorial of that. So this is nothing but k1 factorial, k2 factorial we just saw. And finally I am appending my answer. I am increasing my answer to zero contribution into non-zero contribution. Yes guys, the exact same things that we just gone through. So the same code the same expressions I have written on the code levels. I have done the implementation. The exact same that we discussed, I have just write its code versions of it. Exact same things, right? And the same things that is for loop check of 5. I just copy paste the same things, just copy paste and paste it for loop check 4. What we just need to change? We this for loops. It should be ABCD, and here for ABC for loop check 3. For 2 it's nothing but AB. For 1 it's only A, and rest things exact similar code that I just explained. I have put the same code here. Now there is a DP part is remaining. I will explain the DP part, otherwise you will get a wrong answer again if you not able to understand that, if you are not basically forget the DP part implementation. So there is one things we just missed. Our all calculation is fine, but there is one more things we just missed. So let's suppose we have a number which has x here, y here, and here let's suppose z. Let's suppose here is z. So for this I took my answer by doing the all permutations of combinations of it using the above formula, using the above all things, zero contribute into non-zero contribute. I did it. Tell me guys, as we are running the nested for loops, if it's y, x, z, x, y, these things, that is by nested for loops, this both case can occur. So if we are going to calculate the answer for this case also, is not it redundant? Yes. So both are both are same. Both answer should calculate one time. Both answer should calculate one time, because here is xyz yx and here is yx xy, because for this I took all the combinations. I already considered all the combinations of this. I already considered all the combinations, and these combinations already considered. So for this I don't have to do anything. But if we are going to do for this also, then we are going to get a wrong answer. We are going to get a WA, wrong answer for sure, because for this I already done the calculations of zero contribute into non-zero contribute by applying my formula that we just defined. So that we did. So we just have to skip these calculations. These calculations we just have to skip. So what actually it is? How you can say that this one and this one is identical? So we just need a logic to make both are identical. What it is? The occurrence of the digits. So on first, if you can write it to a dictionary and putting it to a dictionary, something like this. So what is the occurrence of x on the first? 2 times. What is the occurrence of y? 2 times. What is the occurrence of z? 1 times. If I can build a key, and make a note, my x, y, z are x, y, z should be like this. Or let's suppose if this number, if I have 0, 1, 2, 1, 2, something like this. So if I can build a key, 0's count is 1, 1's count is 2, 2's count is 3, then man, tell me, 3's count is 0, 4's count is 0, 5's count is 0, 6 count is 0, 7 count is 0, 8 count is 0, 9 count is 0, right? If I can put it to a string, if I can put this to a string, right? And if I can build a key, if I can consider this as a key, if I can consider these things as a key, right? This entire things if I can consider as a key, am I able to make them identical? Yes, because for both the strings, this key should be identical. The key should be identical. So that is nothing but the occurrence of the digits. But please take a note. You have to iterate from 0 to 9, and you have to consider everyone's occurrence. So don't iterate to the number you have, because on that case you are not following the order, because if you are considering, so 0 occurs 1 times, 1 occurs 2 times. If you are going to write it 1 occurs 2 times and then 0 occurs 1 times, then that is create a different key altogether. Then that is a not match. So you have to iterate how many count of 0, how many count of 1, how many count of 2, and you can make a key with this by doing a stringify of this particular number and its occurrence. If you are able to build a key with this, so when there is a duplicacy, that we just saw on this two, xyz yx yxz xy, when there is a duplicacy with this key, you are able to make one of them is skip. We are able to do the skipping. So exact same things I did. Now I have initialized a DP things, and here you can see I very first I am checking this. I am running a for loop for I in range 10 that we just discussed. We have to run from 0 to 9, and what I am doing, key plus equals to, I have make my key as a string, key plus equals to string of I, and key plus equals to string of dd of I, number and its occurrence, and I am doing a stringify versions of my key is ready, and I am checking if this key is in my DP already. So that means that is a redundant number, that is a redundant calculations I am doing. So don't do man, otherwise you are going to get a wrong answer. So you have already considered this to your last permutations, combinations, formulations. So don't do it. So that's the reasons I have do a if key in DP, then continue. Otherwise I am making any entry to my DP, but we have to make this key to be registered to my DP. This key should be registered to my DP. So I am making my DP equals to key. You can put any value. I am putting 1. You can put any 1, 2, 3 for any. Just you have to register your key to your DP. You have to register, because on next times if there is a key exists to your DP, you are not going to do the computations for this particular number. You have to skip, because that is already pre-computed for the last of its findings. So yes guys, these extra checks you have to put, and if you did all of them, you are definitely going to get a first time AC for sure, first time accepted for sure. Yes, so that's it guys for this particular question and this particular question solutions, explanations, and now let's quickly discuss the time and space complexity for this particular submissions. So what we are doing, I think so we are doing standard nestings. The first loops is going to run from 1 to 9. It is not 10 times, it is going to run 9 times. I can consider it's 10 times only, and there are at max of 5 nesting. That can be for other cases, loop check 4, loop check 3, loop check 2 loop check 1, there are less nesting, but I am considering the max case. So there are 5 nesting, so 5 loops, and each of 10, kind of 10. The first one is for sure 9, but I am considering is as a kind of 10 only. So 10 into 5 loops, so 10 into 10 into 10, it's for sure of 10 raised to the power 5, the nestings we are doing. And extra what we are doing for the last loops, we are again running a each length loop, a loop on the each of LL. We are doing a each of LL here also. We are doing a each of LL here also, right? So that is also a nesting, and I know our LL can grow as big as of 10 size. So there is another 10 hit. So make it 10 raised to the power 6. Okay, now then, are we using any more looping? Yes, I guess one more. Yes, for this. But that is not a nesting of these particular loops. That is kind of a plus. That is kind of a plus of the last nestings. So for this, for the last 10 we have 110 here, another 10 here, but that can be also case based. If it is a modular of k only, then only we are doing. If it is a modular of k, then only we are doing. But let's suppose if it is going to be a modular, then we are doing a 10 here, and this can also go to 10. So there are 2 into 10 here, under this. If it is a modular divisions of k, so 210, right? 210 we are doing here, and then that is under this e, and this is also a 10. There is 310. So last 10 raised to the power 6. So I can write it as 10 raised to the power 5 into 3. I am writing it like for you guys understanding only. So that is of, see guys, how I am explaining, how I am pinpointing my every line time complexity. See guys, see this beauty. 10 raised to the power 5 into 3 into there are 10. 3 10 loops we are doing. 3 10 loops we are doing for the last nesting. So that is the most granular TC of this particular questions. It has on the most critical case, I have to say. So if I can write it now on the good note, it is nothing but 3 into 10 raised to the power 6. So that is the time complexity for this particular submissions. It is 3 into 10 to the power 6, and we know it is obviously less than 10 raised to the power 8. It is very good to on the terms of computations. There is no challenge here. And on space part, what is the space we are using? We are using a DP. We are using a DP which can grow up a size of 10, and we are also building this default tick, which is also can grow a size of 10. Other we are playing only of variables. But yeah, let's wait guys. There is also a factorials we are building. So factorials can also have size of 10, right? The factorials is also of size of 10. So this can grow to 3 into 10. So that space we are using, which is kind of a constant, but that is exactly space things we are using, and that is the time we are using. 3 into 10 raised to the power 6, the time complexity, and space complexity is 3 into 10. So that's all about guys for this particular question explanations, and it's quite difficult to explain. For this is obviously a master level question, that I am agreeing, and explaining is also quite challenging guys, and if you are able to understand, I actually did a half an hour whiteboarding on myself, how I am going to explain what's the steps I have followed to solve these particular questions on the intuitions, line by line intuitions, how I am breaking this particular problem. I literally did an half an hour work on my own to basically like make a kind of note these points I am explaining on this order, and post that I started to making this video. And if you guys are able to understand till this point, and if you really understand and really like the video, like the way I have explain this particular tough, really hard, difficult level question, so please do guys, please do subscribe to our channel, and please turn on the notification, so that when we are going to live with our next video, you are going to get the notification very first. So that's it guys, that's it for this particular video. Let's meet tomorrow with another beautiful question. Bye guys, and happy weekend also.